So over to you, Joseph.
Thank you very much once again for the very wonderful introduction. I'm going to share my screen, which is that awkward moment in every presentation. I was like, I'm going to share my screen now. Okay, here we go. I'm assuming that everyone can see that. All right, thank you very much. Again, to the organizers, it is an honor to be a part of this workshop, something that I feel is very important, so I'm happy to participate. Today, I'm going to talk about RMarkdown. I don't need to say much here because she already gave me a wonderful introduction, but I will paste the slides into the chat so that you have access to that. Everything is on GitHub and is freely available. And I will talk about that in a bit as well. So you can feel free to take a look at these afterwards. You can fork the repo and change things or use them however you feel. That is for everybody else. I get pretty excited to talk about R. I am a bit of a fan. If you can tell, I came prepared for I don't know if you can see this, but for the event. So I'm going to try to control my emotions and not go too fast and not talk too rapidly, anything like that. But if at any point that does become a problem, feel free to let me know in the chat or to put a question on Slido, and I am monitoring that, so I will take a look as well. Well, we're talking about Slido. I do have that on here. Could you put the first pull up, please, if you don't mind?
Yeah, of course. Hang on 1 second.
This first one is just about how familiar everybody is with using RMarkdown. So on a scale of 1 to 10, 10 being a complete expert, how knowledgeable are you about RMarkdown? How much experience do you have with RMarkdown? Get a good idea here. A little bit. Pretty solid variability here. I think I know who the 10 is. But yeah, it looks like the majority is in the 1 region. That's good. This workshop is designed with you in mind, so don't feel afraid. I hope that you'll get something out of this. And then for the people that have much more experience, I think that you will also find that there's something in it for you. At least I hope so. So cool. Yeah, we will be coming back to the Slido after every exercise that we do, so you'll have a chance to ask questions and whatnot. The average is about a 4. That's not so bad. So most people have used it before, but that's okay. We're starting from scratch as if you knew nothing. I did want to take a second and make a comment about the title of this talk, which was, is your code ready for publication? When I first, this was a suggestion for the title, and initially I was like, I'm probably going to change that. And then I thought about it more and more, and I was like, no, I'm going to leave it because I think it's a good opportunity to address this issue head on. And specifically what I want to say, I'm going to give you the answer now. If you were wondering, like, is my code ready? Yes, the answer is yes. I think that a lot of researchers, especially when you first get into coding, have a lot of anxiety about sharing their code. Because like, oh, people are going to see what I did and they're going to think it's really bad. What are they going to think about me? And I think it's really important that we get past that as, well, I guess I was going to say as a field. I'm a linguist, but as researchers in general. And that's mainly because the reason why we want reproducibility is that so we can be aware of our own mistakes, not necessarily for code shaming or anything like that. So I do want to promote that idea. Yes, your code is already ready for publication. Of course, we can always make it better. We can make it more efficient. There's lots of things you can always do to make it better. But the fact that you're willing to share something is obviously the step in the right direction and the most important part. So got that out of the way. What are we going to do today? I have 2 goals. I'm going to talk about what RMarkdown is and why I feel that you should be using it. And then we're going to go through a lot of hands-on examples. I'm going to go back and forth between my slides and RStudio. And we're going to start off with very, very, very simple examples. And then we're going to build up into something a little bit more complex. Depending on how much time we have, we'll see how far we go. We might get into some specific like APA formatted documents. But if not, there are resources at the end so that you can continue. So this will be theoretically the beginning to your journey using RMarkdown, but obviously that's just the start, and there's a lot more that you will learn later on. Awesome. So let's go. This is, I think the best way to start talking about this is what is RMarkdown exactly? And it probably seems quite obvious, but it is the combination of using R code, Markdown, and then getting it together to get a certain output. So what is R? I don't think I need to talk about what R is, but just in case, it is a statistical programming language that we can use to do stats. But it's actually answering this question is becoming more and more difficult because it does so much more than that now. The slides that you are looking at right now were created in R. My website was created in R, and all of that using RMarkdown. So you'll see that it is actually very, very powerful and allows you to do a lot more than just statistical analysis. So what is Markdown? Okay, this is something that you may have less experience with. I'm not really sure. Markdown is a markup language that was designed to help people be able to put stuff on the internet, text on the internet in a format that is formatted without learning HTML, because HTML is kind of ugly and clunky and most people don't want to learn that. So instead of clicking a button, like if you're using a Word document where you would click a button to make text bold, what you do is you put characters or symbols around the words, and that would then be rendered somehow so that you can see bold text, just as an example. The advantages of Markdown are that it's very, very easy to learn. My experience with students is that you can get people to understand it in probably about 4 or 5 minutes. It's not too difficult. For example, here on the left-hand side, you can see some examples of raw Markdown. What it looks like, you can see there's stars around text, 2 double stars for a bold text or for italic. We can use a hashtag or the number symbol for sections. You can create lists, ordered lists, unordered lists. It doesn't really matter. You can do pretty much anything. And this is what it looks like when it's rendered, right? So it's a way to create what you see on the right by writing what you see on the left. Now, what is our Markdown? Well, we combine the two things and we use them to get a different type of output. And I'll take a second here just to mention that a lot of the infographics here, the pictures that you're going to see are for artwork by Allison Horst, who is fantastic. They're all freely available in a GitHub repo, so you can use these for your own teaching materials and stuff. It's pretty awesome. But the idea is that our text, what we write in our articles, for example, and the code that we use to do our analysis should be together, right? We don't want to keep those separate. We want to put them together and then obviously render an output that is something readable for a journal, for example, but everything lives in the same document, a literate document, as they call it. So we can think of this as this is our band for, I don't know, creating research and keeping the band together. So as I just said, R plus Markdown is RMarkdown. And our Markdown document has 3 main components. Now we're going to go into in just a bit, but there's what's called front matter, where you do some of like the main, I guess you could say like metadata of your file. And then there's plain text, where you just write your prose, like an introduction to whatever you're going to talk about. And then there's what's called R code chunks. And we're going to spend a lot of time talking about the R code chunks. Now, it's probably worth mentioning as well that if you are not very familiar with R in general, I won't be teaching R per se today. This is more about our Markdown. So there will be examples where there might be some R code that you don't understand, but that shouldn't matter too much. You should be able to at least use everything, and then you can learn the details at some other point. So how does this work? How does our Markdown do this? That's an interesting question. I mentioned before that R plus Markdown is R Markdown, but there's also something else that works on under the hood, which is Knitter. Knitter is a different package. And what it does is it knits the document that we have. And I'm going to be using that verb a lot. I'll be saying, okay, knit the document again or reknit. And it's worth mentioning that under the hood, what actually happens is a function called render is going to render the document for us. But most people don't ever use that function. A lot of people don't use that function. So most of the time we'll just talk about knitting the document. So when I say that, what I mean is taking the text and the R code and then knitting them together into one single output. Awesome. So Knitter is going to knit the text in the code from an R Markdown file into a Markdown file. So we're going to go from here to here. And then there's another thing under the hood that we won't ever touch, which is Pandoc. And it's going to convert the Markdown file into whatever output we want. And that could be a PDF file, for example, if you use LaTeX, or it could be an HTML file, which is what we'll mainly use today, but also it could be a Word document, which you will also see. So this is pretty handy because there's a lot of possibilities. There's more than what I've listed here. And you might do a lot of your work in Word. Well, that's fantastic. You can still use R Markdown and do your work in Word or produce a document in Word. Some people despise Word and prefer PDFs, for example. That's also a possibility. So there's a little something for everybody. Cool. So summarizing, we're taking R code, we're taking text, we are knitting it together, right? And we're rendering an output document that is going to be a format that we choose. This is awesome because most of the time when people first see this, they're going to think that you're some kind of wizard. They're going to be like, how did you just do that? This is fantastic. This is amazing. And it is quite true. It will do really, really awesome things with very little work at the beginning. The learning curve is not steep, I would say. So it's really cool for a good way for people to get into this, into reproducible research in a very simple manner. Okay, why should you care? This is actually a very easy question to answer. I think just given the nature of this workshop, I'm preaching to the choir, so I won't say a lot about this here. But also, if we care about reproducibility, then this is the first step in the process, right? We need to be generating documents that have our analysis with them, or at least making it publicly available so that people can see what we did. The benefits are clear. You know, people can learn from us, but also we can become aware of mistakes that we might have made because other people can see what we did. So obviously this is a huge deal. It's important for everybody to do. And I think obviously we're building that culture with workshops like this. So I think that's great. So why should you care? Just to rehash what we've said, we're creating dynamic documents using RMarkdown that are completely reproducible. They can be regenerated whenever the code changes or the data changes. This right here, I'm going to stress this because this is actually a diamond. This is fantastic. You can imagine a situation where you need to show your advisor a preliminary analysis of something that you're working on. Fantastic. You write your R code and it's all done. And then imagine a month goes by and you've collected a lot more data, right? You're 50 more subjects or what have you. When you do everything in RMarkdown, all you have to do is click a button and you re-render your report and everything is updated. And that's something, if you've ever done it another way, you learn. This is where you really appreciate the magic of RMarkdown. What else? It makes it very easy to share your results. You can just send someone an RMarkdown document, but you could also put the output in a website, for example, and you could just send somebody a link like the slides that you're seeing right now. And it just makes it easier for others to see exactly what you did. Cool. So how does it work? Again, we already talked about this. We're going to find out right now. We're going to start with our first RMarkdown document, but we do need to do some housekeeping stuff. You do need to have a working version of R on your computer. You also need to have RStudio installed. I'm going to assume that this has all been done, but there are also some packages that we're going to use that you may need to install, probably most of them, but we'll see. You have to use RMarkdown and Knitter. The first time you try to do this, it'll actually tell you to install these, but if not, you can, I'll even paste these in here if you want. You can put these into the console and make sure that you have all these installed. We will be using the tidyverse for the pipe really and for some ggplot, but that's not going to be too important. And then this really, it goes from order of importance, right? The most important at the top, moving our way down. If we have time, we will talk about TinyTech and LaTeX. We'll see how far we get. So if you don't have these packages installed, you can go ahead and do that, or later on when they become necessary, you'll have time. That won't be something to be too concerned about. Okay, so we will start our first exercise. The way that I'm going to do this, I'm going to kind of just live code it for you so you can watch as I do it, and I'd like you to do it with me as we go. And I'm going to put on the left side of the screen, this is going to be too small to see. I'm going to put on the left side of the screen here more or less what we're going to do, as if it was like a quiz or something. So I'm going to make my screen small and fire up RStudio. You can go ahead and do the same thing. Here it is for me. I'm going to have to make this big, make sure everyone can see. Let's see. Can't see the console yet, but the text is probably fine. All right, so the first thing that we're going to do is open an RMarkdown document. There's probably a bunch of different ways to do this. The way I'm going to do it is I'm going to click on this icon on the upper left. It's like a white rectangle with a plus sign, right, for a new document. I'm going to click that. It's a drop-down menu. And then I'm going to scroll down to RMarkdown. Okay, so white rectangle, RMarkdown. Awesome. I'm sure there's probably a hotkey for that as well, but I don't have it memorized. A window pops up and it's going to give me some options here. I'm just going to ignore everything and just click OK. And I'll suggest just go ahead and do that as well. It's going to create an empty document, or no, it's going to pull from a template. And I'm just going to hit Command A, and I'm going to delete everything. Why did I create that if I'm just going to delete it? Go ahead and do the same thing. So we have an empty document with nothing in it. And we're going to do the typical first step whenever you learn something new, right, in programming. And we're going to hello world, for example. Okay, so I've got an empty document. It says hello world. And then I'm going to click this button right here at the top that says knit. And you'll see there's like a little ball of yarn with a needle in it. If I click that, I'll be prompted with another window because it wants me to save the file. So I'm going to save this file. I'm going to give it the name my_ex for my example, I guess. You can name it whatever you want at this point. It's not that important, but just so we know which document we're talking about. And I'm going to save it to the desktop, which I suggest you do as well, so that you can see very easily where everything is. And notice on my computer, I don't know if this is the same for PC, but on my computer, it shows that the ending of the file is .rmd. That's how we know that we're dealing with an RMarkdown document. So I'm going to click save. And ooh, it looks like some magic happened over here on the right-hand side. Things might be in different places on your screens, but it should all be the same thing. And we'll notice that now right here, I can see it's a white background. It says hello world. Okay. And if I look on my desktop, which is where I decided to save everything, I actually have to move it. You'll see that it created two files, right? One is myx.rmd and the other one is myx.html. Okay. And basically what that tells us is that by default, if we just click knit in an RMarkdown document, what it will do for us is generate an HTML file. And really, I mean, it's basically just a website. In fact, I can click this, double click it, and open it in Safari. And I'm looking at it right now. It just says hello world. Nothing fancy, nothing exciting, but we have our first RMarkdown document. Now, the point of this first exercise is actually just to play a little bit with the Markdown syntax. So we're not going to do anything with R yet, but how about this? We're going to go ahead and let's play with what we saw before. Let's create a section. So I'll put a little hashtag before that. I can type some text. You can go ahead and do this along with me. You can't get this part wrong. There's no errors possible. This is a test. And I'm going to make test in bold. So I'll put some stars before it and after it. You'll notice that RStudio notices that these are special characters and gives it a different color. I'll say this is italic by putting 1 star before and after. That's fun. I can create a subsection by putting 2 hashtags, subsection, 2 pound signs, whatever you might call those. I can create an unordered list using a dash. I have to make sure I put a space after. Say this is a list. Very cool. And I can create ordered lists by using number, period, and a space. So this is numbered. Awesome. If I want to, I can even include links to other websites. So I'll do, how about this? This is I use brackets. The text inside the brackets will be the text that's rendered, and then I can put the link inside parentheses right after it. And I'll say, why not give Google some free publicity, google.com. All right. None of this is too important. The details behind it are. I'm going to hit knit again. So magic happens on the right-hand side, and we'll see, oh, it updated my file for me. And now I can see all of this markup in the text that I created, right? My list, my ordered list, my link. And if I return to Safari, or actually put this in the browser, I can update this, refresh this, and I can see there's my rendered text, and it looks pretty. Okay. So that was pretty simple. That's our first taste of Markdown. I'm going to go back to my slides here. Let's just review what we did. So we created a new file in our Markdown, right? We deleted everything from it. So there was no R code, there was no front matter, nothing special. We put in some text. We created some fun stuff with dealing with text. I imagine that most of you noticed that this is probably pretty intuitive and nothing too difficult yet. What were the key ideas? Well, one of the main takeaways from this first part is that our Markdown files are just text files, right? They're just text files. There's nothing to be afraid of. There's nothing inherently special about them, right? They're just text files that end with .rmd. Okay, that's good. We learned that Markdown syntax is actually pretty simple. Nothing too special with that either. And that we can knit our RMD file to get a specific output, right? By clicking the knit button. You'll remember I mentioned before that under the hood, what R actually does is it uses a function called render. But for what we're doing here, we'll just remember we knitted the document. Okay, we're moving. Let's go ahead. I guess there's no questions here if I don't see anything, right? I assume that means there's no questions.
No, there aren't any questions, but I do have one question which is going to be a bit stupid. But you know, when we typed in this is a test and this is italic, why didn't that go to 2 lines? Because you have a kind of enter between them.
Hold on, I'm not sure if I understand the question yet. Why didn't it go to 2 lines?
Yeah.
Oh, right. Actually, this is, you might be like, that's kind of weird. This is definitely a feature and not a bug. Whenever you just have a new line like this, with even if there's 1 space after it, it's always rendered as being part of the same line. What you have to do if you want to break it onto a new line is put 2 spaces at the end, or you could add more vertical space. And this is actually quite cool. This is kind of a little bit more advanced, but if you think about when you write documents, what I usually do is just always 1 sentence per line. Because if you recall how GitHub keeps track of your file, it's always line by line. So you always know if you change a single sentence, you can find where it is in your document. It makes it really easy to use GitHub, basically. But this is more just the style of how I write. So you could also just do it like this, and it's the same thing. Right? If I wanted it to be on a new line in the when it's rendered, 2 spaces, and then it. So I'll knit it again just so you see that. Oh, it was already on 2. Right? This is a test. I could do it like this. I'll do all the options here. Now it's on the same. Right? If I did it like this, now it's on the same still. Right, so if I want to break it, 2 spaces. Yeah, no, that's definitely not a dumb question. That's a good question. It actually ends up being something that's very useful later down the line. But that's stylistic. That's how I prefer to write. Other people might think I'm like obsessive or something. Awesome. Okay, I guess if there are no other questions, I'll just keep going. At this point, now we're going to talk about the anatomy of an RMarkdown document. This is going to be like 3 seconds of slides, and we're going to go right back into RStudio. Specifically, we're going to talk about 2 different sections, I guess you could say. What's called YAML front matter, right? It's something that's going to go at the very top of the document. And then we're going to talk about code chunks, all right? And then we're going to knit this back to HTML again. So let me go back to RStudio. I'm going to go up to the top of my document, and I'm just going to add some vertical space. And then in line 1, I'm going to put 3 dashes. All right, you'll notice that it has a special color. In my screen, it turns blue, and yours, it might turn a different color. And then I'm going to add a space, and I'm going to type output colon, right? Colon. And then I'm going to type HTML_document. Document. Next line, and then I'm going to add 3 more dashes. Now, it's important that you don't have spaces after these dashes. They have to be the last thing on the line. So there's nothing, there's no a space like this, and it'll get mad. Like this, it's fine. Now I'm going to hit knit, and you're not going to see anything different yet. I'm just telling RMarkdown, telling R that I want this to be an HTML document. But you might recall from before that it was already an HTML document by default. But that's fine, but we can actually add other information that's pretty cool here. So I'm going to put in a title. So all right, type title, right, colon, and then in parentheses, I'm going to say my first RMD, close my parentheses, right? And then I'm going to knit again. And we'll notice I have a title now, my first RMD. And I am the author, so I'm going to put author, colon, and I will say Joseph, right? And I'm just going to knit again. I'm just going to keep going through this process so you can see what it does. There's my name, there's the author. I can put in the date. Today, I don't know. Sorry, I don't know the date off the top of my head. It's the 16th, right? Today. And there's probably some other things that we could do, but we'll leave it at this for now. In fact, you can even put art. Actually, I won't put the art right now. I'll show you guys that later. So that's cool. So we have some information that we put here. This section is called front matter, right? The language that this is using is called YAML, but that's not too important. But yeah, we'll call this YAML front matter. Now I'm going to go to the bottom of the document and create some more vertical space. And we're going to do our first R code chunks. The way we do this is we put 3 backticks. You'll notice again in my browser or my console, it's got different colors. I'm going to do curly brace, and then I'm going to type R. Right? This is what is called the opening of the code chunk. And then if I put 3 more backticks, it'll close it. And in mine, you can see that it's a slightly different color, right? To know that this is where it opens, this is where it closes. Now, just like before with the YAML front matter, you can't have any spaces after this line or after this line, or it might get upset. Actually, I don't even remember exactly if that'll happen here, but usually that's the case. And then I can put inside of these code chunks any R code that I want. So I'm going to just do 2 + 2 because I want to. And then I'm going to re-render my document. right? So this is what it looks like for me so far. And you'll notice I have my title, my name, the date, all the stuff I did before. And then as I get lower, I have what I typed into the code chunk and then the output of the code chunk, right? It's always prefaced with 2 hashtags. In my case, that's the default to say like, hey, this is our code coming from the console. And then the 1 here refers to it's line 1 of the output. There's only 1 line, so we only see that 1. And then this is the answer to my math problem, right? 2 + 2 is 4. So there it is. We've done our first code chunk. I'm going to show you 2 more things here. It's very good practice to name our chunks. So I'm just going to say calculator because this is kind of a silly calculator, right? It's just kind of a silly example, but now it has a name. You can't see it here, but if you actually look at what's going on when it's rendered, I'll click on render here, it will talk about the chunks that it goes through. So it's say, okay, RMarkdown render, this is the function it uses to do it. It was looking at just text, and then it got to right here, a code chunk called calculator, right? So it's telling me what it's processing. This can be important for if you have an error, for example. You might hit init and then you get an error. If your code chunk has a name, it'll tell you where to look for that error. Otherwise, it'll just, if it's just blank, let me do this again without putting a name there so you can see what it says. Go back to render. If it's just blank, it says unnamed chunk 1, right? And if all of your chunks are unnamed, it's going to say unnamed chunk 1, unnamed chunk 2, unnamed chunk 400, and that can make it a lot more difficult to find where your error is if you have a really long document. So I'm going to put that back in here, and I'm just going to leave that there. I'll knit it again. There we go. And I'm actually going to go back to my browser here and just update so you can see what that did. So this is what it looks like in the browser, right? So there's my R code, very simple, right? But we're building up a pretty interesting document here. Cool. Let's go back to the presentation. So all we did was set the default for the output, right? We're knitting to HTML. We added some front matter, some YAML front matter, and then we added our first code chunk. Nothing too difficult, but important steps of the process here. So the key idea is the YAML front matter is where we're going to set things up, like what we want the output to be, and other things like our names, the date, the title. We use code chunks to include our code, right? And here I just give another simple example. In this case, I put a comment before the code. That's also a pretty important thing to do that I'm going to talk about in just a minute. I mentioned that we can name our chunks, or we should name our chunks because it makes it a lot easier on ourselves later on when we start making mistakes. And we can generate different output documents according to our needs. Specifically, we've only done an HTML document so far, but we can change that later on. We will change that later on. Awesome. Now we have some questions. When I knit, my RStudio opens up a new window to show the document instead of viewing it in the viewer. Can I change this somewhere? Absolutely. And I actually can't stand when it does that, so I always change mine by default. So I do understand that you don't like that. Let me remember where it is. It might be over here, or it might be, no, we have to go to preferences, I'm sure. So I don't remember exactly where it is, but I'm just going to discover it as I go with you. So general console appearance, RMarkdown, it's probably an RMarkdown. So we'll try here. Show document outline by default, soft draft, show sections. Okay, show output preview in, and mine is in viewer pane. Yours is probably in window. Right? So if you want to, you could change this to window or change it to viewer pane, and it won't do that anymore. I'll set it to window real quick just to show you, but then it already did it for me. Here it is right here. So then you don't even have to open it in Safari like I was doing. I personally don't really like this. So I'm going to go back, and I guess you asked this question because you don't like it either. So I'm going to go back to viewer pane and leave that as it was. But yeah, that's a good question because there are some default settings in RStudio that aren't ideal. I know this is a small question, but how do we get the dots that represent the blank spaces in RStudio? The dots that represent the blank spaces. I'm not sure I know what you're referring to specifically. Could you elaborate on that question?
I think I might be referring to the kind of, like in Word, when you kind of show invisible characters. So, you know, in your case, you can.
Of course, in the text editor. So mine, for example, if I add spaces like this, you can see the dots that they're spaces. Okay, right. That will also be in preferences. It's probably in code. Let me check. Insert your outer text, insert matching. Of course, display makes sense. Highlight, select word, highlights, like show line number, show margin, show white space characters. This is it right here. So in your preferences, under code, display, you have to have selected show white space characters. Yeah, I can't live without that. I absolutely have to have those there. As someone mentioned in the chat that there's also a handy way to insert code chunks rather than typing them by hand. And that is very true. And that's actually what I usually do. There's also a button. If I can see, I might have to make this wider to see insert. Oh, right here. It's like a C for chunk and a plus sign. If I click this, you can insert different type of code chunks. And if you just click R, it'll put one in there for you as well. Right, so I can say and go. Same thing. Yeah. So that's actually a lot easier than typing it every time. The backticks and the curly braces, because you're more likely to make a mistake if you have to type more. So you can use this right here, right? Command I. And if not, you can also use the hotkey, which if you're on a Mac, Option, Command, I think that's an I, Option, Command L. No, don't know what I just did. Oh, Option, Command I. No. My keyboard's different, so I can't find which key it is. But if you want to, there's a hotkey for it. I guess we'll leave it at that. It's quite useful. There are some hotkey. Actually, RStudio has a lot of hotkeys that are actually programmable, so you can customize those however you like. Very cool. Okay, it looks like that covered the questions. And there's always good enough time for a good draping. I like this meme. I mean, it's kind of funny. I guess maybe dated a bit, but it expresses an idea that's kind of conceptually a change in the way that we think of how we work. Right, where normally when you write in any kind of text file document, right, and you continually save it, right, when you're working in RMarkdown, you re-render or you reknit your document and redo your analysis or whatever. So it's kind of conceptually a different mindset. It's pretty cool. All right, we'll keep moving along. How am I doing on time? Doing okay. We're going to talk more about chunks now, more advanced chunking, if you will. This is actually fairly simple, but there's 3 different chunk options that we're going to add into the R code that we've been doing right now. And this will give us some control over the type of output that we get. So I'm just going to stick with these chunks that I have right here. The first one that I want to show you is echo. So if I add a comma, right, we separate our chunks here, the arguments of the chunks, the options by putting a comma. Now I'm going to type in echo equals false. All right. And what this will do, I'll reknit my document. And what you will see is that now I have the output from 2 + 2, but I don't see the R code. So it's saying don't echo the R code when you render, okay? And if I can just change this back to true, you'll see that now it comes back. It's true by default, so you don't have to do that, but now it's here again, right? So maybe when you first start working on your paper, you'll have echo set to true for everything because you want to see the code. But then maybe once you're finished, your finished product, you want to turn it off, right? That's one way that you can do that. Right, so that's echo. There's also another one called eval, which I'll just turn this off. I'll go to eval. Imagine that you have a chunk, for example, that the R code doesn't work yet, something broke and you don't know why. You can set eval to false and it will just render the document and completely ignore this chunk. Okay, so I'll do this again, right? And now I have to set echo to false as well. So the output didn't come out, and now neither the output nor the code will be there, right? It's completely erased. Okay, so the combination of these two can control what we actually see when we knit the document. And another one is include, which actually will do the combination of those 2 things behind the scenes, but it'll actually still knit the code. So I'll set this to include equals false, right? Like this, and it will knit this, but it won't print anything. Right, so we don't see it at all, but this can be handy. Imagine that you do some R code where you actually we'll assign this to an object called X, right? X 2 + 2. Now, if I run this, it'll do it, but we won't see it here. But then later on, for example, here, I'll change this to print X. We can use this because we already saved it as an object. We assigned it to the object X, and it makes it available to us, right? So there it is, print X, and there it is, 2 + 2 = 4. So this can be quite handy because sometimes you'll be typing R code and you don't need people to see that part of your analysis. You just need them to see the result of it. So that's one situation where you might prefer to use include, for example. I just noticed here as well, after the R, when you start your chunk, you can just put a space and then put the name of the chunk, or you can put a comma. It doesn't matter either way. Most examples that you will see don't put the comma there, but for some reason I tend to always put it there. So I just wanted to point that out in case anyone saw the difference between these two, right? With the comma and without the comma, it doesn't matter. Just a heads up. So let me make sure we'll knit it, and then I will update my browser just so you can see it. It does the same thing here. And there it is. Awesome. So we're moving along. Pretty easy stuff. The key ideas so far, code chunks have many, many options. We just saw 3 simple ones, right, that are quite useful for controlling what we actually see when we render our documents. We will go over some more advanced ones as we continue moving along. We can take advantage of them to show, hide, evaluate, include whatever we want. So we can decide what the other person is going to see. The arguments of these chunk options are separated by commas, right? A lot of them that you see are just logical, true or false type things, but we'll also see other ones where we're going to use numbers, or you can even put any legal R code in there. So they will be very handy, as we'll see as we keep going along. Awesome. Back to questions. Can you elaborate using RMarkdown? How can you collaborate using RMarkdown documents? Are there options similar to track changes in Word? Feel free to address this later. This seems like a good time to mention this. I think the best way to collaborate using RMarkdown documents is using some type of version control system like GitHub, which you can see how this goes hand in hand with the previous workshop. For example, a previous question asked about keeping the text on a single line, for example. When this is all tracked in GitHub, then anyone that's following along in your repo can see line for line whenever changes are made, and you can actually make comments in those in the commits. So someone can make a comment, maybe you wrote a paragraph here, and then they have a comment that says like, this is wrong, you need to change this back, something like that. And it makes it quite easy to collaborate. I would say over the last maybe 3 or 4 years, I've started collaborating with RMarkdown and GitHub a lot more. And it's kind of weird at first because it's different if you're used to track changes, but it's actually quite efficient and it works really well. It's just a matter of kind of getting your head around it and practicing a bit. And I do recommend it. I think it's a good idea for anyone that's using RMarkdown. Can you please paste your code in the chat? Yes, I'll just paste this whole thing into the chat. It's probably going to look kind of ugly, but you will be able to copy it. I just noticed there might have been okay, there we go. And is it possible to write comments to self that wouldn't appear in the rendered document? Absolutely. I probably should have mentioned this already as well, because that is quite important. There's different ways to do comments in RMarkdown and R. So imagine in this code chunk here, and you should always comment your code. I should have said this at the very, very beginning. You should always comment your code. If you put a hashtag whenever you're inside of an R code chunk, this is a comment, right? And R will completely ignore this, right? It'll still appear if this is, I'll put this back to true real quick. It'll still appear, but it won't be, whatever you have here won't be evaluated. So it won't give any error. And then you can see this is a comment. You should comment everything that you do. It's a good idea, especially if you're new to R, to just establish this habit from the beginning. Every single time you code something, every line of code, you should have a comment above saying what you did. And you might think that's really annoying. That's kind of silly. I know what I did. You know what you did right now while you're doing it. But 6 months from now, when you come back to a new project because you have an old project because you have new data or whatever, you will not remember. Or if you're like me, you won't remember it. I guess as I get older, my memory is fading. But it is a good idea to always comment your code. Now, what about in text up here? For example, maybe I want to put a comment here because I need to write a new paragraph and I want to remind myself, but I don't want anyone else to see it. You can use HTML comments, which are kind of odd. You do a less than sign and then an exclamation point followed by 2 dashes. And you'll see it made everything commented out. And I'll go on a new line. I'll say, this is an HTML, can't type T, HTML comment. And then you close it by doing 2 dashes and then a greater than sign, right? So this right here is commented out. If I render my text, you won't see it. See, there's no, this is an HTML comment, it's not there. Okay, so that's how you can do comments in the pros, and then the comments in R code chunks are with the hashtag. Both of those are quite important, so that's a good question. Okay, looks like we got all of the questions. If you're getting tired, power through, but it's going to get a little bit more interesting now. We're going to talk about inline code chunks. So let's see, inline code chunks, inline calculations, printing objects, reporting results. Okay, cool. So I'm going to come back here. And I wanted to mention, like, let's see, where should I do it? We'll do it up here with our test. This is a test. This is another line here. We can also, can't find it on Windows or something. Windows. Beak needs help finding an option on Windows. I can't help with that because I don't know where it is, but if somebody knows, they can post it in the chat. We can put R code inside of the pros as well, right? We don't always have to open up a new R code chunk, which can be kind of annoying sometimes. Sometimes we just want to do something simple. For example, I'm going to say 2 plus 2 is, and then right here, I'm going to do an inline code chunk by doing one backtick, a little R, and mine it auto completed, so it has a closing backtick, and then I can just put in whatever R code I want right here. Okay. When I render this, you're not going to see any of the R code. So there it is. 2 plus 2 is 4. All right. Now this is pretty cool because this will allow us to do a lot of other stuff later on. To give an example, there is a data set that comes with R called mtcars. If you're a student of mine, you're going to hate this because I use this data set for everything to show examples, whatever. And we can use any function in R, for example, mean is a function that'll give us the mean of a vector. So I'm going to go call the vector from mtcars, which is miles per gallon. So if I just send this to the console, just to show you what it is, right? This is just a vector of numbers. But let's say this is a data frame that I'm working with in my analysis, and I want to get the mean of this vector, right? I would use the mean function, just like this, right? And it'll tell me the mean is 20.09062. Well, I can also put this into a sentence. So I can say the mean of MPG is, right? And then I'll just join this right here. Backtick R space, and then I have to close the backtick. You'll know if you did it right because it'll be in a different color, right? And then I can knit this, and you'll see there it is. The mean of MPG is, and then it calculates that value for me inline. You can imagine a world where this would be very useful, right? Imagine that you're calculating a mean in your data set for, I don't know, proficiency or some type of score or reaction times or something. You collect new data. If you've done this with an R code chunk, you just knit, reknit, and update, and your values will change automatically. They'll be updated as well, right? So that's quite useful. I could also, let's see, what did I did down here? I did this. I stored this 2 plus 2 as X. I can also call an object in pros. Sorry, I'll just say just that I can also call an object in pros, right? And then I'll say R, and then I'll just type X, right? Because this is already an object that I've assigned, which is the value of 2 plus 2. So this is going to say I can also call an object in pros 4, which doesn't make a lot of sense, but it works, right? I can also call an object in pros 4. Right, so this is quite handy. If you've already calculated means and standard deviations, then you can report them directly inline in your pros. And I'll just go back and update this just so we can see how beautiful it is. Right, so it's down here at the bottom. Right, very useful. I do this in pretty much everything that I write, so it's a handy trick. So there we go. Inline calculations. Let me go big screen again. Inline calculations, right? Printing objects in inline code chunks, and then we can use this combination right here to report results. I've done a very simple example right now of just calculating a mean, but later on we're going to see how we can, for example, report a linear regression model, right? Which will make more sense and be much more useful. Okay, so key ideas. We can use the power of the R console in inline code chunks, right? For example, to get 2 plus 2 equals 4, I typed in literally 2 plus 2 equals and then use the code chunk like that. We can calculate summary statistics, like the mean of MPG is 20, something like that. Literally just typed it in, excuse me, just like that. And we can print most R objects directly as well if we've already calculated. So here, for example, in the example that we've done by hand, I called it X. In this case, I call it the mean, right? The mean MPG is the mean, and it prints it for us as well. So quite handy, quite handy. We'll come back to that. What was the difference between eval and include again? So if you set eval to false, then when you knit your document, R is going to pretend it didn't even exist. It's not going to look at it. It's not going to do anything with that R code. So this is handy for example. Imagine that you're working on something and right now it doesn't work. You're getting an error, but you still want to knit your document. Then you might want to set eval as false, and I'll come back to that later. That kind of thing. Include will evaluate the code chunk. It just won't put it in the document, so you don't actually see it. That's the main difference. And both of those are quite handy as well. I use eval a lot, almost everything when it's when it's in like the testing stage at first, I guess you could say. Include, I don't use it as much, but I probably should use it more. But yeah, both of those are quite handy. Did I miss anything in the chat? Oh, we got an answer. Tools, global options, fantastic. Thank you very much. Okay, I think we'll keep moving along. I think we're doing okay. Doing okay on time. All right, so that is the basics of RMarkdown. You are operational. You're ready to do things. And I think for a lot of people, R can be quite frustrating. But I think that just with RMarkdown, you can see that you can do a lot of very powerful things that are quite easy. So hopefully you guys are more at the bottom picture here than the top one. We're going to keep going. What's next? We're going to talk about stuff that's more aimed towards publishing, towards using RMarkdown for academic purposes. Specifically, we're going to talk about plots and tables and how we can control plotting output. We're going to talk about writing up results. We're going to talk about changing the output, for example, to a Word document or a PDF. And we're going to talk about including references automatically generating a reference section, for example. And then after that, we'll see how we're doing on time. We'll specifically start talking more about APA formatting, since I know your audience, right? Since you guys are psychologists, I assume that you use APA formatting. In linguistics, we use it a lot too. So for this next part, we're going to use a specific project that I already created, and then we're going to go kind of live coding through this document. So what you need to do is download this zip file, which will give you the project. It's an RStudio project, and we'll start working from that. So I'm going to paste this into the chat right there, and I'm actually going to download it and do it with you. So let me...
Joseph, there was just one question on Slido, which is relevant.
Yes. Do you start your analysis with an RMarkdown document, or do you conduct your analysis in regular R file and then move to RMD? This is actually a really good question too. I would say that there is division on how people do this. I have always tended to use R files first, R scripts, but I'm moving towards just doing everything in RMarkdown. So what I would normally do was just write everything in R script first, and then I would just source it into my RMarkdown, because I don't like having really long documents. Other people have had an influence on me. For example, Stefano, who's in the crowd, is someone that I collaborate with quite a bit, and he does everything in our Markdown documents, and it's kind of sticking with me. As a recommendation for people that are starting with this, I think it is probably better to just start with our Markdown documents. I think that the benefits outweigh doing scripts, but there are cases where you might specifically want to do something different. Like if you have something that's very computationally costly that takes a really long time, it might make sense to just separate that into an R file and then source it in later on. There are workarounds for that as well. I'll talk about that towards the end. I think I have it in like the tips and tricks section. But this is a really good question. So like what I recommend to my students now is to just use our Markdown documents. So that would be my recommendation that I give here. And yes, I will copy my code again. I see that in the chat as well. And this will be the last that we're using, the myx RMD file. So that is a good time to paste it in, because that's kind of the end of that one. And now I'm going to close this. And I will download this project right here and see if it works for me. You want to yes, download. Okay, that's a good sign when it works. What this did was it downloaded a zipped file for me. So I'm just going to go ahead and open this. There it is on my desktop. It's called example_project, right? If I open up this in Finder, what you'll see is there's a bunch of different folders here. That the idea is that this looks like a real project that you might be working on for your dissertation or something like that. Obviously, this would be a lot smaller, but that's the idea here, is that we're seeing how we can keep this project-oriented workflow and kind of build out from there. You'll notice that there's also an example_project RProject file, right? So when we open this to work with this, I want you to click on this to open the RStudio. Don't just open one of these single files in RStudio. Use the RStudio project icon, because what that will do is it will automatically set your working directory so that everything that we're doing should just work. So that'll make it nice and easy. So if I look at this, I've just opened it in RStudio. And I'm going kind of slow here. I'm just going to talk a bit because I'm assuming you guys are downloading and opening. It might take a minute. But what I can see here as I look around is that I have on my computer, it's on the right-hand side where I can see all the contents of this folder, right? So if I look here again, this is the same. This stuff is the same as this right here. So that's kind of nice. We have a folder where I keep data. This is just data that I created for this example and the MT cars data set. I have a folder called docs, which is where in my workflows, this is where I would put like my manuscripts for a specific project. And there's a whole bunch of examples here. We're going to come back to this in just a second. I have another one called figs, which is where I usually would save plots. Like if I click on this, you can see it's just a scatter plot, right? So I like to save all of my figures into a figs folder. I have another one called models. In this case, it wasn't really necessary, but if I'm doing like some kind of Bayesian hierarchical regression where it's very big, I usually will save those models as files. That way I don't have to rerun the analysis every single time I reknit, for example. I have a scripts folder where I put a bunch of different R scripts. This is related to the previous question about should I just do my code in an R script and then source it into RMD. Sometimes I do that, sometimes I don't. I put this here just so we could see it both ways. And then I also have a slides folder where I have an example HTML presentation in RMarkdown as well. We probably won't talk about this, we won't have time, but I figured I'll just give you guys the resources so you can play with that on your own. So what we're gonna do, wait, let me double check and see if there are any questions there, see if I can keep going. Looks like we're okay. What we're gonna do is inside of the docs folder, we are going to open up example_project.rmd, which in my screen is the second to last file. So if I open that, we can see that it opens up in my console an RMarkdown document. If I just scroll through it, you'll see that it's got a bunch of code chunks and some pros. All of these examples are all laid out. What we're going to do for the remainder of the time is go through this and play with some of the functions, the new options, new tricks and stuff as we go along. So what do I want to point out at the beginning? We have the same stuff we saw before. There's a title. In this case, I put a subtitles here. There's nothing there, right? The date, you might have noticed I've used an inline code chunk right here to automatically extract the date. I like to do this for reproducible reports. You see what this function does, it just tells you what the date is. So whenever I knit this document, it'll tell me when it was last updated, which is kind of a handy thing to have. You'll notice again that the output is an HTML document. And then there's some reference bibliographic stuff here that I'll talk about in just a bit. So what I'm going to do is I'm actually just going to knit this real quick. Hopefully it works. Looks like it did. That's always a good sign. And you can go through and you'll see that it does a bunch of stuff. I'm going to open this in the browser so that we can see a big version of it, right? Example project is my title. It gives me the date, right? 7/16. It will give me the date and the time. Oops. I can go through. These are just some of the things we're going to talk about. But if you scroll down, you'll see, oh, there's a plot with some data. There's a couple of tables. We fit a model, a linear regression model. There's a paragraph about writing results. And then at the end, there's some references. Okay, so there's some cool stuff that we're going to talk about as we keep going. So I'm going to come back to the console. Actually, I'm going to keep checking slides. I want to make sure I don't get ahead while some questions pop up. So let me just double check this again. No, it's still good. Okay. All right, so we're going to scroll down in the first chunk. And this, I like to do this a lot where I usually will put all of the packages that I'm going to use into like a setup one. This isn't named. Ooh, bad practice. I'm just going to name this setup, right? For this example, we're going to call the library knitter, which you should have installed already. If you've been doing everything, you'll have it. We're going to use the tidyverse, right? We're going to use a package called here and a package called broom. I might not have told you guys about broom before. So if you don't have any of these, you can actually just install them quite easily off of CRAN. You click packages, install, right? And then you can just search for one. So for example, if you don't have here installed, you can type in here and it'll give you here and you can just install it. Or equally, you can do broom and then broom pops up and you can just install it. So if you don't have any of these, go ahead and install them. Now you'll notice by default in my setup, I said echo false because I don't really need this to be printed into my output. Warning false because tidyverse is kind of obnoxious and it has a lot of like, well, no, it actually doesn't have warning. It has messages, a bunch of stuff that comes up like this at the beginning, and I don't want that printed in my document either. But you could, that's optional. You don't have to do that. You'll also notice if you look here in my screen, there's an arrow here. I can click this and run this right here in the console. Like I can run one chunk at a time. I don't have to actually knit the entire document. So that's handy as you're working through an analysis, for example. You don't want to reknit every time. You just want to see the output of that R chunk. You can do that. So that's a handy thing to keep in mind. Now, scroll down a little bit. I'm looking at around line 19. I'm going to talk about some more chunk options. That's a lie. I already talked about these. I'm not really sure why I posted those in there again. Skip that. Go to line 26. We're going to read in some data. All right. So in our project structure, we have a folder called data. And inside of this folder lives a CSV file called simulated data. This is some fake data that I invented beforehand. Right. So we're saying inside of the data folder, give me this CSV file, right? And read it into R, and we're going to call it an object called dat. All right. So if I actually just click this arrow, I can run that and it'll give me this output that this function gives, which I'm not really interested in, right? But I can also look at dat. I could just send that to the console and I can see, oh, look, it's a tibble. It has 200 lines and 2 columns, right? Again, this is just fake data, but it's days and score. In this case, days is number of days without sleep, and score is a score on some type of test. I just made this up. I thought it would be interesting. If we wanted to, we could do other functions to get summaries of this data set and stuff. We're not going to do that right now because really the values don't matter. We just want a data set. So this is how we could load our data into R. You'll notice that in my chunk, I called it load data just so I know what it's doing. I put echo as true, I think for the sake of the example, but you could change this to false if you don't want this information printed to your document, but I'm going to leave it as it is. All right, so that's how we load data in. Now what I want to do is go to the section on plots. And we're going to talk about some specific chunk options that we will need to use whenever we're dealing with plotting data. So if I scroll down, you'll see it says scatter plot, right? And if you run this, it should give you in your console a nice little scatter plot, the one that we saw in the document, right? And that's great. This might be perfect for what I need and I don't need to do anything to it, but it might also be the case that I need to change it somehow. For example, if I have a computer with a retina display, I can make it so that it uses that screen and it prints it in higher quality. So I could set fig.retina equals 2, and that will use like the full resolution of my screen. This is one of those that I pretty much always use. I can also set, this one is probably more important, I could change the width and the height of the figure. So I'm going to go fig width equals, and this is just numeric, so I can say 2, and that means 2 inches, right? I set this, and I'm just going to knit the chunk again, and you'll see what it does. Oh, now my figure is not as wide. Okay, this probably isn't optimal for seeing it right here in the viewer. It looks kind of crowded, right? It might look different if I knit the document again. Let's take a look. Knit the whole thing, take a look. Yeah, look at that, really thin, right? So this is how we control the outputs of our plots that we make in a way that's quite simple. So in this case, I probably want maybe something like 4. I don't know. Just gonna play with it and take a look. Right, now it's wide again. That looks a lot better. All right. I use just this simple example of how to plot, but obviously your plots might be more involved. They use different types of code, or it could be in base R or whatnot. But simple, these are simple options that you have for when you do this. Another one that if you're printing to HTML that comes in handy is fig align. So let me just play with this one, fig align. This is actually HTML code. So I say equals right if I want it to appear on the right-hand side. And this has to go inside of quotation marks. And we'll see is it should move it over to this side over here. Yeah, there we go. Now it's aligned on the right-hand side. All right. Or maybe I want it to be centered. Centered. Knit it again. And now it's in the middle. All right. So these are just some simple chunk options that might be useful whenever we're dealing with plots. There are definitely more, but I don't want to spend too much time if you need more options for whatever you're trying to do with your plots. So I'll leave that as it is for right there. I'll just go ahead and take this out real quick. And I'll talk about tables. Actually, before I talk about tables, I'm going to double check Slido and see how we're doing. Okay, looks like we're doing good. Okay, tables. R is very powerful in how it lets us output data frames, right? And this can be useful whenever you need to create a table for your article, for example. So I'm going to show you some examples of how we can do that. So the first thing that I do here is, let me make this wider so you can see the whole output, is I'm going to use the summarize function, right, to calculate the number of items, the number of rows in the data frame. I'm going to calculate the mean score over the data set, and then the standard deviation over the data set. And then I'm going to do some rounding. The rest of that's not too important. I'm actually just going to run this part right here just so you can see it. Send that to the console, right? So it gives me an output like this, where I can see, okay, there's 200 observations. I already knew that. The average score is 57.79, and the standard deviation is 6.52. Cool. you can imagine a situation in which I would need to output that to a table for a document, for example. And there's a handy function from the knitter package called cable that will do that for us. So if I just run this, it gives me a table. If I look at it in my knitted one, you can see, okay, it's right here. This is an HTML table. It's kind of ugly, probably not too useful, but it works. It's a possibility. You can also render to different formats. So I rendered format pandoc, but and actually, if I do this, will it show me? I might have to send it directly to the console, but you can see what this looks like. This is what it's doing under the hood. It's generating a table like this. And then when it's rendered in Markdown, it appears like this. So this is like the simplest type of table. It's kind of ugly. It could also, I think you could also choose Markdown as an option. Check out. No, wait, that's not, I want to copy that. So I have to put it directly in the console, otherwise you won't see what the raw code is. Yeah, and it makes it in a Markdown table if you've ever seen these before. Or you could even do, in some cases, it might be useful to do HTML. With the same thing, and you'll see it's hideous HTML code, right? HTML surprisingly might be more useful than you would expect, because what it does is if you're knitting to a Word document, Word understands HTML. So if you do anything in HTML in your RMarkdown, Word can translate that, which is actually super useful if you have if you work in a field where you use special characters, for example, like IPA characters. If you're a linguist, you can use like an HTML version of the IPA character, and it'll render it for you in a pretty format. And in that case, you see here, I have results set as is. That means what R actually reads is this code right here. If it's not as is, then it can render it in the document in a different way. That I wouldn't worry too much about the details about that now, because most of these functions that give you tables will actually, it knows how to do this automatically. So it's not too much of a concern. So that is how we can make some simple tables. I'll show you another example where we do it with a linear regression model, which is probably more useful than what we've seen so far. So in this code chunk, I'm using the DAT data that is simulated, right? And we're going to run a linear regression where we look at score as a function of days, right? Just the scatter plot that we saw before. And I'm going to assign this regression to an object called mod, right? So I'll run the whole thing and then go through piece by piece. If we see it, yeah, it calls it right here. So the first thing I did was assign it to mod, and then I looked at a summary of the model, and we can see the summary right here. So this is nice. This is a nice table that we can interpret our coefficients and find out if we have an interesting study or whatnot. It gives us all kinds of information here, which is good, but we need something that we can include in our article, right? So one way that we can do that is to put it into a more summarized format. And for that, we're going to use this function called tidy, which was from the Broom package that I talked about before. And if I'll submit that real quick, and let me just show you what it does. It takes the model and it puts it into a nice, pretty format, right, where I can get what I might want to actually put into a table. So it took the, let's see it. Let me put it out here again. It took, oh, I don't want it console. I want it. There we go. It took this right here, and basically it took this middle part, right, and it put it into another data frame as what a table specifically. Up here, it created into this. Now that is something that I can use to do a lot more really cool things. So check this out. I can take that mod tib and I can send it to the cable function like I just did before, right? And that'll give us something like this, right? Which is what you see if I scroll down a bit in our knitted document. That's what you see right here. So this is actually the output of our model. If you want something prettier that uses a lot more of the details from the summary function, you could use the sjplot package, and they have a function called tab model. You would have to install this because that wasn't part of what we talked about. So if you don't have this and you want to try it, you can do search for sjplot in packages, sjplot like this, and install that. I already have it installed. You'll notice I had it as eval as false because I remembered that you guys don't have it. But I'm going to set this to true, and we'll just take a look at what this does. Very cool. So it gives us probably a more useful output of a regression model where we can have it's nicely formatted. We can see the p-values are nicely formatted. It tells us how many observations, and it gives us the r-squared values right here, r-squared and adjusted r-squared. So if I reknit this document, it'll automatically include this table inside the output. Here we go. Where is it? Right here. So this is actually quite nice. This is much better, something that's probably more useful for a reader than this type of output right here. So if you are interested in that, you could use the sjplot package to the tab model function to do that. And it works with a really wide range of models. It can work with linear mixed effects models. If you use LME4, it can work with BRMS models. If you do Bayesian analyses, it's quite flexible. All right, let's check some questions. Would it be possible to paste your code again, this specific document or the one previously? I said this one, you should have the whole file. I don't think I've changed anything. Respond again if you wanted the other one. I can open it again. The titles you put in the R code chunks, like describe table, doesn't actually print in the RMarkdown file. Is the title just for our knowledge? Yeah, I say for your knowledge or for my knowledge, just so I remember what I'm doing. So that was just descriptive statistics of that table. That's why I called it, I gave it that name specifically. Yeah, whenever I'm writing R code chunk labels, it's always just for me so I remember what I was trying to do, because as I mentioned previously, I'm very forgetful. Is it possible to print model in a LaTeX format to copy paste into tech document for? You absolutely can do it into a LaTeX format. We'll do that. We'll try that in just a second, and it will automate all of the stuff that we just did. It's actually quite beautiful if you use LaTeX. I find that in my experience, there's less and less people that use LaTeX. We're a dying breed, but it is possible. So I will come back to that question in just a moment. Let me see what's next. No, that will come back pretty quick. No, shall leave that as it is. I think it'll work with LaTeX as well. Okay, so what we've seen so far is some chunk options and things that we can do for plotting and for printing tables. Now we're going to talk more about reporting results from the same model that we just fit. And this is where I think some of the major benefits of using RMarkdown come in for researchers, where you have to do a lot of publishing, right? So you can imagine a context where we actually write a paragraph up. The prose is like this. I wrote this really fast, so there might be mistakes or it might be weird. But we want to say something like what we did. We analyzed this data using this. The outcome variable was that, blah, blah, blah. And then what are the results? The model estimate for the intercept was this, this, and that. And this is basically just the model, the information that we would normally take from the table, right, and paste it into our prose. Now, since we already established an object, right? In our case, it was called mod_tib. I'll put that in right here, right? That has all of these values. Then we can use the magic of the console, right? And use inline code chunks to call these values from the table, right? So you'll notice that I say the intercept was, and then I say, give me the first row of the second column, right? First row, second column, give me this number right here. And that's exactly what's printed, 76.25. Plus or minus 1.75 standard errors, right? And you see right there, 1.75. If I added more data and reran the analysis, since I've done this in a programmatic way, all of these values would just automatically be updated, right? So the benefit here is we get rid of those copy and paste errors, right? That we normally have to do when you get your analysis results from one entity, from R, from SPSS, and then we have to move to like a Word document, for example. So this is one way where we really see the benefits of keeping it all in the same place. Right? This might not be exciting, or it's kind of ugly in some of the way it's typed out and stuff, or if you don't really know how to wield data frames yet, this might seem foreign, but it's actually quite simple once you get the hang of it. So that's a good example. There are other possibilities. For example, there are some packages that kind of automate this process to some degree. For example, there's one called Report. It's part of the Easy Stats package. In fact, I would recommend, if you want to, you could install this package real quick. It's already installed for me, and you can see that it does something. I go back and forth about whether or not I like this or not. From a teaching standpoint, I don't really like it, but I don't know. Anyway, what it does is if I run this, it'll take that model and it'll actually already spit out like pre-formatted paragraphs with the results in it, which I think is interesting for like learning how to do it, but it also scares me because I want students, for example, to be able to get a summary from an output model and actually write up their own paragraph. But it does give like a template for how you could describe this. So you'll notice, let me set this to true, eval true, and I'll reknit this document. So use this with caution, I guess, maybe if you want to tell people about it or students about it or not. I don't really know, but I use it and it gives me the, actually, let me set, just so you can see this prose. Results equal as is. So what you can see is it put it in as like a markdown R comment, but I want it to come out as like actual prose that I would put in an article just so you can see it. There you go. So we fitted a linear model estimate, and it gives all these details like template, spit it out with the same values. Okay, I didn't type any of this. This isn't my writing or my thoughts or anything like that. So You can imagine a world where this might be useful, but also another world where it might be dangerous. But in any case, it highlights, it illustrates how you can get the model or get numbers from a model and automate the process where you don't actually have to type it in by hand and make copy and paste errors. So consider how you want to use that. I guess I'll leave it at that for now. Let me go back to the questions. Is it possible to choose how many figures after the decimal are displayed when calling values from models tables in the pros? Yes. What I did, because when I initially created this document, for example, I had a number that was super long. And what I did in the tidy function right here, I tidied it and then I used mutate to actually round it, right, to two decimal places. So you could do the same thing, right, and round it to do 2 decimal places. That's why all of mine come out with 2. If you don't do this, if I took this away, for example, it would have like 5 decimal places, which is kind of annoying. So it is possible to do that. There's a function in R called round that'll take care of that for you. All right, cool. So we've been working with HTML documents this whole time, which can be helpful, but maybe most of us probably to Word. I might get some errors. I've changed some things that might not be compatible with Word, but we're going to see. So I changed it to Word_document. I just went ahead and reknit. And there we go. Mine spit out a Word document. It doesn't look like it had any errors, which kind of surprised me. And I can see it's already pre-formatted with Word's standards, right, for the colors and the sections and stuff like that. So we have the title, the date, everything that we saw before, and then everything that we saw in our HTML document, our pretty plot, everything is here, right? If I scroll down, I have to reformat this table because I left it as HTML. I can see the output in the code with the code chunks, and I can also see the tables that were created. I have to change the output for this one as well. Yeah, I didn't know if this was compatible with Word or not. So that one's, I think, is HTML only. But in any case, you can see how that. Let me see. Actually, maybe if I don't put anything, let's see what it does. It'll probably just put it as a comment. But anyway, it gives me the paragraphs where I wrote the results. Right, all of this came out. It's actually pretty. It's not bad. That's pretty. Scroll back down. This table came out pretty good. The other one, this one doesn't seem to be very compatible with Word, but it might work better with LaTeX. We'll try in a minute. I changed this to a comment. Yeah, so more or less you get a feel for how it works. We'll talk about the reference section in just a minute, but there you go. You can change the output. Now, somebody asked about LaTeX, so we can do that as well. What you have to do in order to use LaTeX is install TinyText first. If you already have LaTeX installed on your computer, which actually in that case, I assume that you do because you're asking about it. People that don't use LaTeX don't usually ask about it. And then in that case, all you have to do is change this to PDF document, which I will do now. And you'll see that it'll automatically generate a beautifully formatted PDF document, assuming it doesn't get any errors. Oh, it put it on my other screen here. All right. So now I have the same thing in a PDF, which is also worth its weight in gold. I love that. The graphics are vectorized, so you can scroll in and it looks nice. I have to fix the tables again, but you can see this one came out nice. This table was formatted automatically. And the writing results part, this is all the same, right? Nothing different there. This one I have to reformat as well. Let me change that. Yeah, it should be the same folder. Oh, sorry, I missed that question. Yes, this document is saved automatically. That is a good question. So wherever the RMD file lives is where it's saved. So you'll see here I have example project HTML, PDF, and now I should have the Word one, example project Word. So all 3 of them are right here. Our studio just opens it automatically for you right after you knit. I want to change one more. I want to try one more thing with the table. This one. Let's see what this does. I don't think this is going to work, but we can try. Check one more thing in the documentation here, and then we'll move on. See if it takes. No, this only works with HTML. Okay, yeah. So this one's not gonna work for us in the PDF, but it was worth a try. There are other packages that will print to PDF for us. I just didn't put one in here. Yep. All right. So that's pretty good. That came out pretty nice. So let's write in results, different outputs. Awesome. So we can go back and forth between Word, HTML, and PDFs. I wanted to talk about reference sections as well, because obviously if we're writing articles, we want to include bibliographies. If you use LaTeX, you probably already know about .bib files, and RMarkdown plays really nicely with .bib files. All you have to do is add where the bib file lives into the YAML front matter. So you can see I did that already right here, right? And so if you look in the files inside of docs, there is a file called rreferences.bib. So here it is right here. I'm just going to go ahead and open that and show you what it looks like, right? There's only two references in here, right? The manual for R, base R, so for citing R, and then for citing the R papaya package, which hopefully we'll get a chance to talk about. And in order to cite any of these, all you have to do is actually use this title, this name that you give it right here, and you refer to it in your R Markdown. So let me scroll back to the bottom. So you can see, what did I do? Reference name. Oh, so right here, I say, for example, we did our analysis in R, and then I cite base R, right? So I put it inside of brackets. I use the @ sign, and then I put in that name. So it was R-base. And what we'll see in the output, if I go back to my viewer, we'll see that it comes out like this. It says R core team 221. That's what it is rendered to. And it automatically puts it in the reference sections right here, right? And you might be thinking, okay, we use APA, we need APA formatting. You do that using a specific class, a CSL file, right? So I got one here called APA CSL, which I noted right here, right? And then that'll automatically format it in APA format. I could use any type of CSL file that I want. So you might be writing for a specific journal that has its own format, and you might need to use the way they do it. You can find an absolutely enormous resource of all of the CSL formats, and that lives in this GitHub repo right here. Every single one of these is a format, and the list just goes forever. It's actually insane. So it's really nice because you don't have to worry too much about having a correctly formatted bibliography. It's quite easy to do. And this is, as I said, I chose the APA one for you guys, and it works out quite well. I think we have time to talk about a papaya document. So I'm going to do one more thing. Let me check the questions first, see if we're doing okay. Can we change the folder where the output is saved? Yes, you can. You can also in the YAML front matter, you can assign where it's saved. Well, you know what? You'd have to do it in like a knitter option, a chunk option, and I don't know how to do that off the top of my head. So I would have to go through and figure it out. So I won't address that right now, but I'm 95% sure that that is possible. I think a simple Google search would help you find that information. But I can't answer that question off the top of my head, unfortunately.
More in the chat, but I think that's just.
Oh, sorry, I've been ignoring the chat.
No, sorry, I should have asked them to post a Slido. But can you call from Mendeley or similar?
Ah, yes. There is what's called an add-in. You notice right here, there's this thing that says add-ins. There's one, I don't know if I have it installed. Let me check. There's one for references for Zotero. There's a refresh. I think I uninstalled it when I updated and I haven't put it back in yet. Okay, so there is an add-in that you could look for. It doesn't look like I have it, where it will actually, once you have the .bib, that can get it from Zotero, for example, and then you can just search through your bibliography and it'll put it in formatted for you automatically. I really should have added that in. That's a bummer because that would have been a nice thing to show you guys. It's magic. Yeah, so there it is right there. Thank you. It's called Cite R, the add-in, and you can install it, and it works like magic. It really is quite useful. I'm actually surprised I haven't reinstalled it yet. And it gives you this function right here for an add-in for insert citation. All right, let's just watch the GIF here. And you can see, you can see how it's going through, he's searching through his bib file. And it's another one of those moments where it's like the first time you do that and it works, you're like, this is magic. Why didn't I do this my whole life? It's actually fantastic. So I would actually recommend checking that out as well. I will post, no, the link is already in the chat. So you have the link. I will show you one more thing. If you go back to the docs folder, you'll notice there's also a file called example_APA. We're going to open that one. And this is a pre-formatted template that comes from a package called Papaya. So you would have to install that package, which I did not give the code for, I forgot. Let me bring this up. So if you GitHub Papaya, I spend like my entire life on this repo. And I'll paste in the code to install it. This is assuming that you have, assuming that you already have LaTeX installed. Right, if you want to and you're interested in this, you could run this code. Other, you could just watch as well. It's not a big deal. But what I'm going to do is I'm going to knit this document, and you'll see that what it does, which is quite handy, is it's going to give us an APA formatted article, different from the one we did before because that wasn't formatted already. So you have the running head, the title with the line numbers, everything that you theoretically have to do for APA format. It takes care of that for you, and then it just uses the same R code chunks like we've seen with everything else. It's quite wonderful. I think I'm probably everything that I've published in like the last 5 years has been with this Papaya package to format to APA. It does have some quirks, but I find it to be really useful. And the maintainer is great. He's always on the GitHub issues, answering questions and stuff. So it's a pretty good package. I like it, but it does have its quirks. So that's something I would recommend checking out if you're interested in knitting directly into an APA format. And on the GitHub repo, there's examples of other studies that have used it, all kinds of good stuff. So let me go back to my Slido. We are running out of time. There's no questions here on Slido. I will come through. I just wanted to point out, so I mentioned, and what we've used so far has just been HTML, Word, and PDF. But RMarkdown allows you to do a lot more stuff. So you could also use Bookdown. A lot of people are using that to write books, but also for dissertations. You can do tough handout reports, you can do slides, you can do websites. I mentioned before that my website is all in RMarkdown, as well as these slides that you're seeing right now. Let me make this big. So I definitely, this is one of those rabbit holes where you start using it and then you start using it for everything. For those of you that are interested in using RMarkdown a lot more, I would say just start using it for everything that you do, homework assignments or anything. You can use RMarkdown for it, and the more you do it, the better you will get. I hope that the goal of this talk, I guess, was for those of you that know about R and you want to do reproducible research, but you're used to working in these formats over here, to kind of narrow this gap to help you get over there, I guess you could say, past the valley of heartbreak. And this is especially true when you want to be on this side over here, but you collaborate with people that only work over here. I think that our Markdown is filling that gap that help us cross the valley of heartbreak. Also, I know there's different levels of R skill. People that are here today, everything that we've done in RStudio is kind of independent of being good at R. So I think that actually in R Markdown, I think that's a good thing. And just kind of, I mean, everyone starts somewhere, and the more as you go along, you'll get better at it. So I would encourage you not to get too frustrated. And I do want to include some extra links that are also very useful. More about reproducible reports, boost your R Markdown skills. These are both kind of like advanced topics in using R Markdown. R Markdown for Scientists is a huge book that's fantastic. It's how to use R Markdown, but thought specifically for people like us that need to do research and publish in journals. All of the chunk options that you could possibly want are here in Yuhui's blog. He's the maintainer, the creator of Knitter. And then there's another Bookdown website with everything about Papaya if you're interested in knitting specifically in APA format. So with that, I hope that you enjoy R Markdown and that you consider using it for your research. I'm pretty sure, yeah, that's the end. It says here 36 slides, but if you continue, there's more tips and tricks and advanced topics, things that you can think about. And that is it for me. I guess there might be some more questions that I can respond to. If not, but otherwise, thank you very much for your attention. Thank you very much to the organizers for inviting me. Lots of fun.
Thank you so much. There are a couple of questions. I'll wait till you answer them, and then we can, people have already started uploading, so.
Sure. Do you have any recommendations to how to learn to use CSS if we wanted to use R Markdown for said presentation? Yes. I mean, I Google everything. That's exactly what I do. For example, for this presentation, there was lots of funky CSS quirks that I pasted in, like for the title slide. And I would say, I mean, think carefully about what you want to do, because the most important thing is asking the right question. Because most of the times, if you have that question, somebody else has had it before you and they've asked it already. So you can check, Stack Overflow type websites and stuff like that. My experience with CSS, I've gotten fairly good at it, but it's all been trial and error. So I would recommend doing that. There are some packages that can make it easier though. Some packages to check out. For example, I use Shining Gun for creating slides, and there's a package called Shining Gun. I think it's Themer. Shining Gun Extra is the main one that has all kinds of cool CSS tricks that you can that you can use to make your slides do fun things and stuff like that. This is probably not too relevant, but I'm curious, how do you embed live chat results into your slides? So this is using HTML code. It's just an iframe. It's not too bad. It's relevant because it's our markdown, right? I'll show you real quick the code. It'll just take me a second. So let me make this smaller. So the talk that you just saw, right, this is just an RStudio project. It's called RMD workshop, right? And it's just an RMD file, right? It's called index.html. And you'll see here, this line right here, it's just an iframe where I pasted in the link to the Slido, right, that I got from the Pathways to Open Science PDF. And then once I paste in the iframe, it just appears in the slides. So it looks like magic, but really it's quite simple. It was quite handy to be able to go through that and to see the questions like that in real time. Have I missed any other questions in the chat, maybe?
Just one question in the chat that I think hasn't been posted to Slido, which is how do you collaborate? And I think you answered a version of it before, but how do you collaborate in drafts of papers with comments or changes? I guess the collaborators need to be happy with using RMarkdown too, or you'll be going between Word and RMarkdown at the time.
Yeah, that is a great question, and it's kind of a challenge that most of us have been dealing with when you're working with people that don't use RMarkdown. My experience, there's kind of two ways of going about it. If the person uses GitHub, then it might not be a big deal because GitHub has track changes in a different format, but they work quite well. If the person that you're collaborating with does not use GitHub and does not use RMarkdown, then you're probably using something like Box or like a Google Drive or Dropbox or something like that. And what you can do, what I've done in these instances is where I'll have the RMarkdown file live in whatever service we're using to share our documents, and that person will only look at the knitted document. So in this case, it would be like a Word document. So I would knit to Word. They can do track changes there, and then I would just have to incorporate whatever they said into the RMarkdown file and then reknit. In which case you have to be careful because you can lose your comments. There are some packages that work specifically with this in mind, like to go from a Word document back to an RMarkdown document, but I haven't tested them yet, so I don't know how well they work. But they do exist. It is a problem, I guess you could say, that people are trying to tackle right now. It can be tricky. Anything else?
I think that's all the questions, and we're perfectly on time, so that's really great. So yeah, I guess all of it is for us to say thank you so much. Loads of thanks already pouring in the chat. That was super useful. I think it also took it from really simple to fairly advanced. So some stuff.
Yeah, okay.
Just there. But yeah,
Awesome.
Thank you so much. And thanks also for all of the resources and being part of the course. Hopefully you'll come and join us for our evening drink, your afternoon drink.
I actually have to teach in 5 minutes, but I will try to. As soon as I get out of class, I'll come back. And I'm going to paste into the chat also the GitHub repo for everything that we saw today, because all of the resources, obviously, as I mentioned before, are available. So that'll help people play around and explore all these things as well.
And I guess, yeah, so I'm going to stop recording now. And if we can just take the time to give Joseph a nice virtual round of applause.